Hey everybody, so in this video we're going to be looking at angles of elevation and depression. So here it says a 6-foot man walks on level ground toward a 45-foot flagpole. So let's go ahead and do that. Let's say we have some 6-foot man. So here we'll note that he is 6 feet tall and he is walking toward a 45-foot flagpole. So here, okay, so we know this is 45 feet tall. He notes different angles of elevation theta to the top of the pole. Okay, so the angle of elevation is inside the triangle here. To the top of the pole when he is different horizontal distances x away from the pole. Okay, so here's what that means. As the 6-foot tall man is walking towards the pole, the horizontal distance is continuously changing because he's getting closer and closer to the flagpole. And then the angle of elevation here is also changing because he's going to have to look up higher and higher and higher the closer he gets to the flagpole. So it says, express the man's horizontal distance from the base of the pole x in feet as a function of the angle of elevation theta in degrees. Now, this sounds, overly complicated, but it's really not. All they want you to do is to set up the problem. So here I'm going to say tangent of theta is equal to 45 divided by x. Now, something I want to check on, is 45 the right number to use? 45 is the height of the flagpole from the ground up. But they give us information at the beginning saying that the guy is 6 feet tall. So really here, if we're talking about the angle of elevation from his eyesight, it's 6 feet shorter than this number. So instead of using 45, what we need to say now is from the guy. So let's write it out like this. We'll say from the ground up is 45 feet. But from where the man is looking, it's going to be 45 minus 6. So that's going to be 39 feet. So I want to make sure that I change that here in my ratio. So here, we'll make this 39. Now it says, express the man's horizontal distance. Okay, so we're solving for x here. So in this equation, I need to solve for x. So we know that when we have right triangle trig, here what we have is proportions. So we can cross multiply and solve. So I have here x times tangent of theta equals 39 times 1, which is 39. And so what I'll do here is divide by tangent of theta. So I will get x equals 39 divided by tangent of theta. Now here, this is a function that will solve for the horizontal distance. So if you wanted to find any horizontal distance as the man continues walking, all we need is the angle of elevation. All right, on B it says express the angle of elevation theta as a function. So here we're solving for the angle of elevation. So remember, anytime you're solving for angles inside triangles, we have to use inverse trig. So we know that the ratio is tangent of theta equals 39 over x, and what they want us to do is solve for the measure of the angle of elevation. So here what I'll have to do is multiply by inverse tangent. So whatever I do to the right, or the left, I have to do to the right. So theta is going to be equal to inverse tangent of 39 divided by x. So this would be a function of how you would find the angle of elevation. So it would just be inverse tangent of 39, the height of the flagpole that the guy is looking at, divided by whatever your horizontal distance is here. So the reason that we're using variables is to represent that it could be any degree of angle of elevation or any horizontal distance, and the formula is still going to be the same. All right, that's going to be all for this video. If you have any questions, please leave them in the comments, and we'll see you all in the next video.